Good afternoon. Welcome again to our lecture series for the plane and spherical trigonometry subject. So going back to the last lecture that I posted, so we discussed some practical application of trigonometric identities and trigonometric function. So in this topic, we're going to discuss some important identities and proving identities. So we are going to, I'm going to give you some uh, sample problem with solution for you to better understand the topic. So again, this we are on chapter 2, lecture 5. So I'm going to introduce to you the 8 fundamental identities, and we are going to prove other identities by simply using these 8 fundamental identities. So there will be an activity on the graphing of the trigonometric function. So I'm no longer discuss this topic. So we're now going to proceed to the main topic of this lecture, which is trigonometric identities. So there are 8 trigonometric function or identities that we're going to tackle. So make sure you familiarize or memorize this trigonometric function since this will be used in proving some identities. So we have three main category. We have the reciprocal, the quotient, and the Pythagorean. For the reciprocal, we already know this one that the cosecant of the theta angle is equals to 1 over sine since the cosecant is reciprocal to your sine theta. So cosecant theta is equals to 1 over sine theta. So next will we have secant theta. So we all know that this is reciprocal to 1 to cosine theta. So cosine theta is equivalent to 1 over cosine theta. So that is the second uh, trigonometric identities. Next, we have the cotangent theta. So we all know that the last topic we discussed that your cotangent theta is just reciprocal of your tangent theta. So cotangent theta is equivalent to 1 over tangent theta. Okay, for the next category, we have the quotient relationship. So, we're the quotient. For the tangent theta, di ba, si tangent theta is opposite over adjacent, in which the opposite of that side is the sine theta, and the adjacent side of the tangent angle is equivalent to cosine theta. So, which means your tangent theta is just equivalent to the quotient between sine theta over cosine theta. So, again, your theta is the angle that we are referring to. We have also cotangent theta. So cotangent theta, since this is adjacent over opposite, so which means ang natin adjacent is a cosine theta and the opposite is a sine theta. So if you are going to examine tangent and the cotangent, we just interchange sine over cosine. So in this cotangent, since reciprocal din siya, so we just reverse cosine over sine. So if you take note of this one, sine over cosine for the tangent and for the cotangent is cosine over sine. So we just interchange this one since they are reciprocal, yung ating tangent and cotangent. Okay? So next category, we have the Pythagorean relationship. So for the Pythagorean relationship, we have sine squared theta plus cosine squared theta is equivalent to 1. So to check if this trigonometric identity is correct, you can substitute values of theta. You can substitute values like, for example, 10 degrees. So you write sine squared 10 degrees plus cosine squared 10 degrees. Then you check, then the value of that is equivalent to 1. Okay, so this is the, I think this is the sixth trigonometric identity. Now we are going to the second. We have 1 plus tangent squared theta is equivalent to secant squared theta. So similar with this one, 1 plus cotangent squared theta is equivalent to cosine squared uh, theta. So this is the 8th. Medyo complex is the sine squared. So this is madali lang, sine squared theta, cosine square root of theta is equivalent to 1. Another 1 plus tangent squared theta plus secant squared theta. I have 1 plus cotangent squared theta is equivalent to cosecant squared theta. Okay, so let's now have there are some examples on how are we going to prove some trigonometric function. So before we start with the proving, so let's discuss first this one. We have the trigonometric identities. So when we see identities, this is an equation involving the trigonometric function which is valid for all values of the angle, for which the function are defined is called a trigonometric identity, which means this function is equivalent to another function of a trigonometric identity. So a trigonometric identity is verified. We can verify if the two function of trigonometric function is equivalent to another function. We can verify by transforming one member, either left or the right member, or the left or right equation into the other. So in general, one begins with more complicated inside. In some cases, each side is transformed into a new same form. So for me, mas inuuna ko yung complicated na function kasi mas madali siyang i-transform into another function. So let's try some problems. So these are the guidelines on how are we going to verify or to prove some identity. So there are some function which is very complicated and diri ka maaram kung can we prove this function equivalent to this other function. So these are the guidelines. So no need to follow the guidelines, but just to make sure you understand the flow on how are we going to verify these identities. Make sure for number one, you should you should know the 8 basic relationships. So yung 8 basic relationship, yung na-discuss kanina, yung third slide, yung reciprocal, the quotient, and the Pythagorean identities. Know the 8 basic relationship and recognize alternative form of each. Kasi pwede siyang alternative, pwede siyang i-transform, pwede siyang kunan ng reciprocal. So know that the procedures for adding and subtracting fractions, so basic algebra must be employed here in and verifying identities. Reducing fraction, how are we going to reduce fraction, and transforming fractions into equivalent fractions. So very basic algebra. No factoring and special product techniques. So you need basic knowledge on factoring, special products in your algebra will be used here. Use only substitution and simplification procedure that allow you to work exactly one side of an equation. Select the side of the equation that appears more complicated. So this is why I'm referring to. Ano yung equation na medyo complicated kasi mas madali siyang i-transform. And attempt to transform it into the form of another side of the equation. If neither side is uncomplicated, transform each side of the equation independently into the same form. So, kung medyo madali lang both equation, you can transform both. Pwede mo isabay yung dalawang equation. Avoid substitution that introduce radicals. So, medyo magiging complicated masyado yung proving identities pag mayroong mga radicals. So, just use the fraction para mas madali. Use substitution to change all trigonometric functions into expression involving only sine and cosine and then simplify. Multiply the numerator and denominator of a fraction by conjugate or either. Simplify the square root of a fraction by using conjugates to transform into quotient or percent square. So you just follow this guideline. So let's have an example where we are going to follow these guidelines. Now, let's have an example. Tangent theta plus 2 cotangent theta is equals to sine squared theta plus 2 cosine squared theta over sine squared cosine squared theta. So we are going to verify if this left side and the right side equation or expression is equal. So either you select the left side first, then make it this one, or you can use this one and then transform this para magiging ganito na yung hitsura niya. Okay? So how are we going to do that? So by following the guidelines, so first just remember that mas maganda pag inuna natin yung medyo complicated yung kanyang expression. So based on this formula or this equation, we can say that medyo complicated yung sine squared yung right side. We have sine squared theta plus 2 cosine squared theta over sine theta cosine theta. Now, can we prove this with this expression to this one? So by writing, so we can start by, so let's start with the right side. So our goal is yung right side natin is magiging similar kay left side. So let's start with sine. So natin sine squared theta is plus 2 cosine squared theta. That is all over 2 sine theta cosine of your theta. So that yung goal natin is magiging tangent theta plus 2 cotangent theta siya. So if we simplify this equation, so we can, pwede nating hatiin yung sine squared theta plus 2 cosine squared theta. Tapos i-remain natin yung kanyang denominator in each partition. So pwede natin gawing sine squared theta over sine theta cosine theta plus yung kabila, yung 2 cosine squared theta over sine theta cosine theta. So, dapat wala tayong tatanggalin, similar lang din. So, this equation here is just similar to this one, similar sa nasulat natin dito. So, you're right, similar lang, you're right, do. So, which means similar dito. So, anong pwede natin gawin? So, since sine squared to, since this is sine squared, and meron tayong sine, then we can cancel out yung sine, isang sine. So, we can simplify by just, since sine squared to, tatanggalin natin siya. So, matatanggal din to. Yung remaining natin sa taas is sine theta na lang. Another, since cosine to, this is cosine squared, and mayroon tayong cosine sa baba. So, the remaining, since squared to, so the remaining is cosine theta na lang. So, sulat natin ulit. So, ito ay magiging sine theta over cosine theta plus 2. Since cosine na lang yung cosine squared kasi tinanggalan natin isang cosine. So, magiging cosine theta na lang over sine theta equals to so 2 tangent theta, 2 cotangent theta. Balik tayo. Let's continue. If you see this one, sine theta over cosine theta, pag binalik natin yung 8 trigonometric identities, di ba yung sine theta is equivalent kay tangent theta. So ito ay magiging tangent theta. And this one here, di ba, cosine, ito ay cosine theta over sine theta. Pag binalik natin yung 8 trigonometric identities, yung equivalent ng cosine theta over sine theta is cotangent. So, this is now cotangent. So, pag simplify, since ito ay tangent, this is tangent na, this is cotangent. So we can say that that is tangent theta plus 2 cotangent theta. That is equals to sa left side natin, which is tangent theta plus 2 cotangent theta. So, is this similar? So, yes, similar na siya. So, we can prove that your sine squared theta plus 2 cosine squared theta over sine squared theta cosine theta is equivalent to tangent theta plus 2 cotangent theta. Okay, so this is the flow. So, what if we are, paano pag left side yung ating gustong i-transform para maging the same kay right side. So, you can also do that. So, but medyo complicated yung process. But if you follow the, the, the simplification of the fraction and the following the trigonometric identities, you can prove that this right side is equivalent to the left side. Okay, so let's have another problem. Okay, let's try this another example. We have tangent x plus cotangent x is equivalent to cosine x, cosecant x over cosine x. Okay, by simply looking into the equation, so just determine which is more complicated and which is more madali siyang matransform. So for me, I want the left side to be transformed para maging, let's prove that left side is equivalent to the right side. So we just copy the equation, okay? So that is tangent x. So I want the yellow color. We have tangent x plus cotangent x should be equal to, let's prove that is equal to cosecant x over cosine of x. So again, we are going to transform this left side para magiging right side equal siya. So let's prove kung equal ba talaga. So by simply looking at these two equations, yung ating tangent x is equivalent to sine x over cosine x. Paano ko siya nasabi? Because using the trigonometric identities plus yung ating cotangent ay equivalent to cosine x over sine of x. So let's just write do or the same. So by simply looking into this equation, pwede natin siyang i-factor out or by fraction, that is cosecant x sine of x. Diba? Pag si cosecant x sine of x divided by cosine of x, so matatanggal yung cosine x, the remaining is sine x na lang. So this will become sine x times yung ating numerator na sine x plus, dagdagan natin, baka magkulang. Yung ating cosine x, denominator na cosine x sine x divided by dito sa sine x. So, matatanggal yung sine x. So, yung remaining is cosine na lang. We have the cosine x times yung ating numerator dito sa taas na cosine x. So, let's simplify further. So, yung ating, if we multiply this to sine x times sine x, that will become sine squared x plus yung cosine plus another multiplied by another cosine, that is cosine squared x over cosine x sine x. So let natin do. Okay, so ano pang pwedeng gawin para yung goal natin is magiging cosecant x over cosine x. So if you can see on the numerator, we have here sine squared x plus cosine squared x. So this is the Pythagorean identities. So yung sine squared x plus cosine squared x is equivalent to 1, di ba? So yung ating equation ay magiging, simplify natin yung ating equation, magiging 1 over cosine of x, sine of x na lang. Write natin do. So, since yung goal natin is magiging cosecant yung numerator, and tapos cosine yung denominator, meron na tayo ditong denominator na cosine. And then, kailangan natin tanggalin yung sign kasi yung goal natin, cosine lang yung nasa denominator. So, kung balikan natin yung identities, yung 1 over sine x, ito, ay equivalent kay reciprocal ng 1 over sine. That is equivalent to cosecant of your x. Diba? 1 over sine x equals to cosine x. Cosecant x over, copy natin yung denominator na cosine x. So, if you write, we have here cosecant x over cosecant x. Okay. So, therefore, yung ating tangent x plus cotangent x is equal to be cosecant x over cosine x. So, we can prove that value. Okay, let's try another problem. So, you have here secant x over, you have secant x over cotangent x plus tangent x is equal to sine x. So, in this example, medyo halata naman na medyo complicated yung ating left side compared sa right side. Kasi kung sa sine x lang, tapos yung goal natin is magiging ganito, medyo mahirapan tayo matatagalan. So, let's try, yung ating uunahin is si left side. So, sa left side tayo, secant x over cotangent x plus tangent x na magiging sine x siya. So, let's have here si secant x. Meron tayong secant x is equivalent to, ano ba yung equivalent ni cotangent x? Yung ating cotangent x is equals to cosine x over sine x. Diba? Plus, yung ating tangent. Ano ba yung equivalent ni tangent? Yung ating tangent is sine x over cosine x equals to do. Do natin is sine. Can we simplify further this equation? Okay, pwede. So, we can simplify the denominator first. So, simplify natin using the denominator, magiging, so, mayroon pa tayong space dito. We have secant x over, simplify natin, we have the sine x, cosine x, yung denominator. Sine x, cosine x divided by sine. So, the remaining is cosine. So, magiging cosine squared x to plus cosine x, sine x times divided by cosine x. That is, matatanggal yung cosine. So, sine na lang times dito sa upper na sine squared. Magiging sine squared x siya. That is do. So, anong pwede natin gawin? So, pwede natin yung ating ditong pinaka-denominator, pwede na natin ilagay sa taas. So, this will become sine x, cosine x, times secant x over, we have cosecant squared x plus sine squared x equals to do. Okay? So, from the equation, di ba yung ating, from the identities, itong cosine squared, sine squared ay equivalent to 1. So, magiging, if we simplify this equation, magiging sine x, cosine x equals to secant x equals to do. So, yung goal natin is, itong whole na equation here is nagiging sine x na lang. So, how are we going to do that? So, take note na pwede nating ma-simplify yung ating cosine and yung secant. Okay? So, sine x, right sine of x. We have tayong cosine of x. Ano yung equivalent ng secant x? Diba, yung reverse or reciprocal ng secant x is equivalent to 1 over cosine ni x. Do tayo. Diba? So, cancel out natin si cosine. So, the remaining is sine x. So, sine x equals to sine x. So, therefore, yung ating secant x over cotangent x plus tangent x ay proved to be equal to sine x. Okay. So, let's try another problem pa para mahasa. Okay, we have here another example. We have sine x over 1 minus cosine x is equal to 1 minus cosine x over sine x. So, if you can see in the two equation, parang pareho lang siya. But if you look into this, the numerator, well here, 1 minus cosine x, and the denominator, we have 1 plus cosine x. So, this 2 here is called conjugate. So, when you say conjugate, it's just the same, but only the sign is different. Okay. So, by, as I mentioned in the guidelines, diba? We can simply multiply this trigonometric function using its conjugate. So we try. So let's try this one. If we are going to use the left side, so let's so we have here sine of x over 1 plus cosine x. Since conjugate yung 1 and yung ating denominator sa left side and the numerator on the right side, we can multiply this equation by 1 minus cosine of your x, since conjugate siya, over sine of x. And yung conjugate niya na 1 minus cosine of x equals to do. So, let's multiply this one. Since conjugate to, yung ating dalawang denominator, 1 plus cosine x times 1 minus cosine x, diba? So, this will become 1 minus cosine squared x. Tapos, yung sa numerator, multiply natin sine x times yung 1 minus cosine of x equals to do. So, ano yung ating nakikita dito sa ating equation? So, let's focus muna dito sa ating numerator. So, yung numerator natin is 1 minus cosine squared x. So, yung goal natin is magiging 1 minus cosine x over sine x. So, paano natin ito masimplify? Diba, from the identities, yung ating sine squared x plus cosine squared x is equal to 1. So, if we transfer this cosine on the left side, or on the right side, magiging sine squared x is equal to 1 minus cosine squared x. Okay? Alright? So, ibig sabihin, yung 1 minus cosine squared x is equivalent to sine squared x. So, therefore, itong ating denominator ay magiging sine squared x na. Okay? So, this will become here. Sulat natin. Sine x times 1 minus cosine x over sine squared x equals to, so the same. So, by looking at the equation, ano pang pwede natin i-simplify? We can cancel out sine dito and sine dito. So, the remaining would be 1 minus cosine x over sine x. And this is equal to the right side, which is 1 minus cosine x over sine x. So, therefore, yung ating sine x over 1 plus cosine x is equivalent to 1 over cosine x over sine. Since conjugate lang siya. We have here 1 minus cosine x over sine x. Okay, since conjugate lang yung dalawang function. Okay, we have here another problem. Okay, let's try this problem which involved a radical. So we have here square root of the second x minus tangent x over second x plus tangent x. So let's prove if it's equal to the right side is equal to 1 over second x tangent x. So let's start with, we are going to identify first which side are we going to simplify. So for me, since merong radical yung ating left side, ito yung ating ita-transform. Okay, we have here. So, copy natin si square root of, ay mali. We have the square root of second x plus yung ating tangent x over second x plus tangent x. Minus pala to. We have here minus. So, yung ating goal is magiging 1 over second x tangent x, yung ating nasa radical. So, if you can see, conjugate yung ating numerator sa kanyang denominator. So, which means, pwede natin siyang i-multiply by its conjugate. So, either, nasa sayo lang yan kung numerator or denominator na conjugate mo siya i-multiply. But our goal is yung denominator is magiging square ng kanyang conjugate, which means kailangan nating yung denominator, yung numerator niya, yung conjugate ng numerator, yung ating i-multiply. So we have here second x plus tangent x, second x plus tangent x. So we multiply our function here by the conjugate of this numerator, ang conjugate nito which is second x plus tangent x. Kasi yung goal natin is yung denominator is magiging square. Okay? So simplifying this one. So let's try. We have here to simplify this equation. We have here second x minus tangent x multiplied by second x plus tangent x all over yung ating second x plus tangent x squared. So, may squared na siya. So, by simply looking at this equation, so we can simplify the numerator. So, by simplifying the numerator, we have here. So, we just need to copy the last equation to have a more space. So, again, we have here second x minus tangent x multiplied by second x plus tangent x all over, meron tayong second x plus yung ating tangent x, then squared. So this will now become yung ating numerator. We can simplify the numerator. That is secant x minus tangent x times yung ating secant x plus tangent x. That will become secant squared x minus tangent squared x. Yung ating denominator na secant x. Okay. Secant x plus tangent x, that is squared. So, ano yung pa yung pwede natin gawin para ma-simplify yung ating equation? So, let's take a look of the numerator. Tingnan natin yung numerator. We have the secant squared x minus tangent squared x. Hindi pa siya familiar. So, from sa ating identities, meron tayong 1 plus tangent squared x sa ating Pythagorean identities is equivalent to secant squared x. Ibig sabihin, pag yung ating tangent x squared, i-move natin siya dito, magiging 1 is equal to secant squared x minus tangent squared x. Ibig sabihin, yung ating numerator ay equivalent to 1. So, if we simplify our equation, magiging, we have here, square root 1 over secant x plus tangent x. So, since ito ay squared. So, square root of this value, square root ng 1, and then square root ng secant squared x plus tangent na may squared. So, this will become 1 over, since naka-squared yung ating lower, yung ating denominator, so this will become secant x plus tangent x. So, therefore, yung ating square root of secant x minus tangent x over secant x plus tangent x is equivalent to 1 over secant x plus tangent x. Okay? So, that is correct. Okay? So, I hope you follow among those sample problem. So, you just need to practice and know or understand the basic 8 trigonometric identities. Okay? So, let's have here another example of the factoring and simplifying trigonometric functions. So, let's have here for example A, we have A is equals to sine of your theta minus cosine of your theta times sine of your theta plus cosine of your theta. So, this is just, you just employ the knowledge on college algebra para lang tong x minus y and then x plus y. So, if you multiply this two, this will become, paano na to? X squared, then plus xy minus yx minus y squared. So, since these two, you can cancel out these two here. So, the answer will be x squared minus y squared. So, since yung ating x squared o yung ating tinitreat na x ay si sine, so this will be the sine squared theta, and yung y squared natin ay si cosine squared theta. So, therefore, yung ating equation ay magiging sine squared theta minus cosine squared theta. Okay. That is for letter A. So, let's try letter B. So, meron tayong, for B, we have sine A plus cosine A. Meron ditong squared. So, if we multiply this one, ito ay magiging sine A plus cosine A and multiply by itself since ito ay naka-squared. This is sine A plus cosine A. So, this is sine squared A plus cosine A sine A plus another cosine A sine A plus cosine squared A. So this will become sine squared A plus 2 cosine A sine A since dalawa to plus cosine squared A. So this now, how are we going to square the two trigonometric functions? Okay? So the same with the remaining problems. You just employ the factoring in the common factor in the operation in the algebra. So you can use just the same. Let's go with the other sample problem here. Okay, we need to, for this problem, we need to factor out the given equation. We have, so let's try with letter A. So, si ating letter A, we have here, A is equals to sine squared theta minus, I'm sorry, I need to delete that, minus sine theta cosine theta. So, ano yung pwede natin i-factor out? Meron tayong sine dito, and we have sine squared here. So, this now become sine theta. We have here sine theta minus cosine theta. So, this is now the simplest form since wala nang pwedeng ma-factor out. Okay? For letter B, meron tayong sine squared theta plus sine squared theta cosine squared theta. So, since meron tayong sine squared dito, meron tayong sine squared, so we can factor out sine squared na diretso. So, this is equal to 1 plus cosine squared theta. Okay? Diretso lang. So, let's try letter C. Try natin yung letter C. We have sine squared theta plus, meron tayong sine theta, secant theta minus 6 secant squared theta. So, kung titingnan nyo, medyo complicated siya. So, if we employ algebra, so, let's just say yung ating sine ay equal kay x and yung ating secant ay equal kay y. So, yung maging equation natin is x squared plus xy minus 6y squared, di ba? If we factor out this equation, magiging, di ba, dalawa. So, since x to, x, and then factor out 6y squared, na dapat positive yung kanyang value. So, factor out ng 6 ay pwedeng 3, then 2. Erase muna natin space. Lagyan natin ng space. So, pwede nating 3y. Yung isa is 2y. So, we need, since positive itong xy, dito plus, at dito ay minus. Diba? So, if we factor out this equation, our answer would be the same as this one. So, this will become sine theta plus 3 secant of your theta. And then, yung isang factor ay sine theta minus 2 secant of your theta. So, if you want to check, just multiply this equation if the answer is the same. So, Okay, that will be the last sample problem. So I hope you learned something out of this video. So if you have question in mind, since medyo complicated yung proving, you can send me a sample problem. If you cannot solve it, and maybe I can help you, and you can ask question directly, PM or message me if you have questions regarding this deep proving. So one thing for sure is you need to familiarize with the a trigonometric function in order to prove some identities. Okay, so if you have question regarding this one, take note. You can message or PM me. You can look for a example of a sample problem on proving. If you cannot prove, maybe I can help you out. So, okay, thank you, and thank you for listening. So, see you on the next episode of our lecture.